Hi guys, and welcome to this MaffsGuru video on sequences, part of the Year 12 Further Maths course. Really good to see you here. Sequences is the start of a brand new section I'm going to get into just in 1 second. If after you do me a small favor, over in that corner is a little doohickey that's pointing to subscribe to my YouTube channel. Really appreciate it if you would subscribe and tell a few people out there that I'm here. Now, sequences, what is this all about? Well, by the end of today's video, we are hoping to have the idea of what a sequence is, how to create a sequence, and to know some of the key language involved, because further maths, language, and more language is going to get you through this course. And the good news is I'm going to show you how to use your CAS to find sequences or numbers. It is so easy, it is almost laughable, and in a moment you will laugh. Now, believe it or not, you've been dealing with basic sequences way back. You learned to count, and then chances are we started teaching you your times tables. And you can see here that the 2 times table is shown here, and that is a pretty ordinary example of a sequence. Here is our start value. Now, I'm going to be very careful about the idea of start values. In this situation, we've chosen to start at 2, but sequences don't have to start at 2. I mean, I could have started my 2 times table at 6. I could have done 6, 8, 10, 12, and 14. Why would I do that? Who knows? But part of a question may say to me, start your sequence at 6. I could have started it at minus 10, minus 8, minus 6, minus 4, minus 2. I could have equally started it at 0, 2, 4, 6, 8, 10, and so it goes on. All of these numbers here, this 6, this negative 10, and this 0, would all be called my start number for this sequence. And there are some special language and special formulae typey things that we use that's coming up in the next video. So there's my start value. What about a term? Well, believe it or not, there's actually 7 terms already shown here. A term is nothing more than a number. Each of those values, 2, 4, 6, 8, and 10, is called a term. Now, what is the rule to go from term to term? Do you see what I did there? Term to term. What is the rule to go from 2 to 4, from 4 to 6, from 6 to 8, and 8 to 10, and so it goes on? Now again, way easy, but believe it or not, this section of the course isn't particularly complicated. It's the language that tends to throw people. What's the rule? Well, hopefully it is plus 2. Yup, very good, plus 2. Add 2, all sorts of different variations that we can use for the language there. And wow, what are these dot here? I mean, well, that's called an ellipsis. I know, strange, huh? But what that means is that the term or the sequence continues on, yeah? In this situation, that dot means we'll keep going, 16, 18, 20, 22, 24, to infinity and beyond. Well, that's the actual language done. Believe it or not, I don't think it gets much more complicated than that. Now, Cambridge, Further Maths textbook, or the Cambridge people have very kindly said I can use their examples, and thank you so much for allowing me to do that. They literally are awesome, and it makes my course 10 times better. But here's example 1. Write down the first 5 terms. What's a term? A number of the sequence. Thank you very much. With a starting value of 6. There we go. So there's my start value of 6. And the rule, add 4 to each term. There we go. So I want the first 5 terms. 1, 2, 3, 4, and 5. Now I do the little lines under there just to make sure that I know how many of these I need to do. So I'm going to add 4 to each term, so that gives me 10, 14, 18, and 22. Ladies and gentlemen, there we go. We are done. Told you it wasn't difficult. And here is example 2. Write down the first 5 terms of a sequence. Thank you for 1, 2, 3, 4, 5. There's the gaps I'm going to fill in with a starting value of 5. Yep. And the rule, double the number and then subtract 3. Okay, they've thrown a multiplication rule in here. Not particularly complicated. Double the number and subtract 3. So 5 times 2 is 10. Subtract 3 gives me 7. Thank you very much. 7 times, what do I do? Double it. 7 times 2 is 14. Take away 3 is 11. 11 doubled is 22, take away 3 is 19, and 19 doubled is 38, take away 3 gives me 35. Oish! That was starting to get mentally strenuous, yes? But in this situation, I could have used my CAS calculator. Oh my goodness, are you kidding me? Look at that. Perfect segue to the next section. Using the CAS is actually really easy. I'm going to bring up my CAS calculator. Repositioning so it's in the screen. There we go. This is the Casio ClassPad, which I use. If you're using a different calculator, don't worry. The rules are fairly similar, all right? Or the processes are fairly similar. But we're going to use a calculator to generate the first 5 terms of the sequence with a starting value of 5 and the rule double and subtract 3. Okie dokie. So the first thing I'm going to do is I'm going to actually get my stylus and I'm going to hit main so that it works. Now when you do this, the starting value, you actually put that into your calculator first and you hit execute. So there we done. I've done 5 and hit execute. Now what I'm going to do then is I'm now going to type my rule exactly as it says, double. So I'm going to do times by 2 and I'm going to subtract 3. Now you'll notice my calculator with a red arrow just pointing to it says ANS. And all that's saying is take my previous answer, double it and take 3, which is effectively like saying take my last term, double it, take away 3 and give me my next term. So when I hit enter, out comes the value of 7. Whoop, whoop. Now all I actually need to do is hit enter again and it remembers my last calculation. Out comes 11, then 19 and then 35, which just so happens to have been the numbers we've done before. Now I could keep doing this until either my calculator breaks or I get incredibly bored. And I'm incredibly bored. Ladies and gentlemen, that is actually this video on sequences. Thank you so much for taking the time to watch. It wasn't very long, was it? The next one's got a little bit longer. It's good to see you. Thank you very much. If you haven't already done so, there is a doohickey over there for you to subscribe. Greatly appreciate it if you could do that. And a video loading from the Further Maths series that you might also like to watch. Have an awesome day. I look forward to seeing you in the next video. Take care. Bye-bye.